Hello everyone, hope you are doing well. Today we are going to discuss the most famous interview problem called Josephus problem. This is Algo Conqueror. Let's get started. So we are given n soldiers who are standing in a circle in an order, and we are also given a K. And initially the first soldier holds the knife. Now the first soldier kills the kth soldier after the knife hold. The problem states that kill the kth soldier after the knife holder. We are given k is equal to 1. Let's assume k is equal to 1. So this guy will kill the first person after him. So second soldier will be killed. The knife will be passed to the next soldier after second soldier. So now the knife will be with Now the knife will be with 3. So we have taken away the knife from first, and it's getting messed up. The knife will be with 3, and now 3 will kill the first soldier after him and pass on the knife to the next soldier. So 3 will kill 4 and give the knife to 5. And now knife will be with 5. So now 5 will also kill the kth soldier after him. K is given 1. 5 will kill the first soldier after him, who is 1. Now 1 is killed, and the knife will be passed to the next soldier who is alive, which is 3. So now knife will be with 3. Now 3 will kill the first soldier after him, which is 5, and he will be the winner of this game. So he killed 5, everybody else is killed, only 3 is remained. We have to return 3. 3 will be our answer. This is basically the Josephus problem. I hope you understood it. So think about it. There are, I know, 2 approaches for solving this problem. First one is the brute force. So let's start with the brute force. Give me a minute. Now think in terms of linked list and modifying linked list. The hint is it is use circular linked list. So please pause this video and give it a try. Now let's take, if you are given n, which is, let's take 5, and a case which is 1, I'm going to take a circular linked list which has n nodes, 5 nodes. So I'm creating a linked list 1, 2, 3, 4, 5. This is a circular linked list. I hope you know the implementation of circular linked list. It has a next pointer, and the tail again points to head. This let's say this will be our head, and this is our tail. Tail will point back to head. That's the circular linked list. Now what I'm going to do is, I hope you know how to remove a node from a circular linked list if you are given a reference. So what I'm going to do is, let's take the knife is with first guy, and I'm going to kill the second guy. it basically means I have to remove the second guy from the circle. So what I will do is I'll modify the links, and I'll point the next pointer of 1 directly to 3 so that I'll remove the second guy from the circle. So that's how now the circular link list becomes this. So it will look something like this. And we have 5. 2 is now gone, and the knife is with 3. So 3 will now remove 4 and directly connect to 5. Now in the next move we will only have 1, 3 and 5. This is how circular linked list gets shorter and shorter. The circle gets shorter. We have to continue this process until we are left with a single node, which will basically be 3, as we saw earlier. This will be the brute force. So what will be the time complexity? Each time you are removing one node until we are left with a single node. So initially we had n nodes, and we are removing each node every time and until we are left with a single node. So the time complexity will basically be big O of n, right? And what about space complexity? Space complexity will be, we are taking a circular linked list of n nodes, right? So space complexity will always, will be big O of n. Now let's solve this using recursion. There is another approach called recursive approach to solve this problem. Now I'll discuss that. I hope you understood the problem, how I solved in the brute force way. Now let's look at the recursive solution. So we are given, this is our problem. This function solves the Josephus problem of n nodes, and we have to kill the kth person after the current knife holder. This will return the number of this will return the number of the survivor. What will this function return? It will return the number of the survivor. In this case, we saw earlier that we will be left with the 3 will survive in this game. So this function should return 3 in the end. So that's what this function solves. Now, can you think this problem in terms of subproblems? So you are killing each soldier and the number of nodes are reducing by 1. Can you think in terms of recursion? I'll just make things more clearer. For n is equal to 5 and k is equal to 1, the problem looks like this. And how will the problem look like for n is equal to 4 and k is equal to 1? It will look something like this, right? 1, 2, 3, 4. And knife will be with the first soldier every time. As you see here, the knife is always with first soldier. So Josephus of 4, 1 will solve this problem. And similarly, when n is equal to 3 and k is equal to 1, we will have 1, 2 and 3 that will be with 1. So the knife will be with 1. Every time, the nature of Josephus, the function finds a solution for only these kind of problems when the knife is with 1 and the numbers are in order. Josephus can find solution for only these problems. Let's assume that. Now we are given with this problem with n is equal to 5 and k is equal to 1. The knife is with the soldier 1. Soldier 1 kills the second soldier as k is 1 and passes on the knife to the third soldier, right? So how will be the problem looking like? It will look something like this. The knife is with 3 and there are 4 nodes now, and the nodes are not in order, and the knife is not with the first soldier. So in order to we will take 4 nodes, and Josephus of 4, 1 looks like this. All right. If we solve for this problem, and here 1 is mapping to 3 and 2 is mapping to 4, 3 is getting mapped to 5 and 4 is mapped to 1. If we solve for Josephus of 4, 1 and convert those nodes back into our actual answer, we will get the actual result. This is our assumption, and we are converting it back to the actual answer. So each time we are going to kill a soldier and call for the Josephus subproblem, and whatever answer it returns, we will convert it into our actual answer. 1 is getting converted to 3 and 2 is getting converted to 5. 3 will be converted to 5, 2 will be 4, 4 will be 1. So here I have written this. 1 is, we should convert 1 to 3, 4 to 1, 2 to 4 and 3 to 5. Now if you look carefully, 1 plus 2 is 3, right? 2 plus 2 is 4, 3 plus 2 is 5, and here 4 plus 2 is not 1. I'll show you why. We are having nodes like this, right? 1, 2, 3, 4 and 5. We are basically moving in a circular manner. 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5, 4 plus 2, there is nothing here. We have to get again back to 1. So this is basically the circular increment. 4 is getting converted to 1. So we are almost at the end of the problem. We have to find an equation which converts the RHS to LHS. Can you think of an equation? We have n is equal to 5 and k is equal to 1. N is 5, k is 1. You have to find an equation which converts Josephus subproblem into actual solution. Alright. These are Josephus subproblems and these are actual solutions. You have to find a way to convert this to this. 1 to 3, 4 to 1 and 2 to 4 and 3 to 5. So I previously told that 1 plus 2 is 3, 2 plus 2 is 4 and 3 plus 2 is 5, but 4 plus 2 is 1. So this is the case where we were failing. So in order to handle it, we should use circular increment. Circular increment is nothing but, I'll write an equation, you just check whether it works or not. Let's say this is y and these are x. Can I write x is equal to y plus k mod n plus 1? You just cross check this equation. will it satisfy for every y? You should just check. Let's substitute 1 in this equation. If we substitute 1, 1 plus k is 1, 1 plus 1 mod 5. 2 mod 5 is 2, 2 plus 1 is 3. Yes, we are getting it correct. Now let's substitute 4 here. If we substitute 4, 4 plus 1 mod 5 is 0. 4 plus 1 mod 5 is 0. 0 plus 1 is 1. Yes, it works. Let's check for 2. And if we substitute 2, 2 plus 1, 3 mod 5. 3 mod 5 is 3 plus 1 is 4. Yes, it works. And for 3, 3 plus 1, 4. 4 mod 5 is 4. 4 plus 1 is 5. So this is how you should convert the Josephus subproblem which was assumed, and the assumed one we should convert into actual one. This is the assumed one, this is the actual one, right? So what can I say? I'll just write the final equation for you to understand. Josephus of n comma k is equal to, this is basically x, right? Josephus of n minus 1 comma k plus k mod n plus 1. This is the whole equation. If you know this, you can do Josephus problem. This is the actual solution, and this is the assumed one. And in order to convert the assumed one into actual one, we have to use this equation as I have written here. So this is how you solve this problem. So I hope you understood the solution. Thank you very much for watching this video. That's it for this video, guys. Thank you.